So I made an outline of what it appears to me that is happening with mathematics, so that I could sort of perceive the wholes a little bit more accurately. Um, so one of the prerequisites for mathematics is numbers. These are descriptors of scale. They are a prerequisite, but they're not actually a part of mathematics. They occur outside of mathematics. But ironically, mathematics is nearly universally treated as being entirely about numbers. So that strikes me as interesting. And then the other part that you need is units. So these are the categories of things, which is why set theory and mathematics are commensurate. Now, when we combine these, when you have a unit and a number, or a scaled unit, that's a vector, right? And this is the fundamental object which mathematics actually operates over. Okay, now the basic branches of mathematics. The first one I had to add because it didn't seem to be a recognized branch of mathematics. Measurement. This is where everything starts. You have to start with measurement. And when you're taking a measurement, you're taking a measurement of a vector. You're taking a measurement of a scaled unit. Right. And the measurement is more or less the discovery of the vector scale. It's generally, you've kind of established the unit. So we're just discovering the scale of that unit. So we're discovering the magnitude of the vector with measurement. One step up from that, we get to arithmetic. And arithmetic involves the rescaling of vectors. And that's really about it. And then there's also geometry, which is, in my opinion, it's really in the same field, it's in the same ballpark as arithmetic, because what geometry is about is rescaling vector spaces, where arithmetic was rescaling vectors. So, are those different? And then a step up from that, we get to algebra, and this is the relative rescaling of vectors. So basically, we're operating with generally more than one variable here, and we're looking at how they scale relative to each other. So, anytime we're working with dependent and independent variables, the dependent variable, what we're doing is we're looking at how it scales relative to a rescaling of the independent variable. That's basically what algebra is. So it's about rescaling the vectors. We tend to keep the units the same across all of these, right? And then kind of the next step up is analysis, which includes calculus and diffie-q and some other shit. This is mostly going to be about the relative change in rescaling of vectors. So you might notice that all of these, measurement, arithmetic, geometry, algebra, and analysis, they are all about the scale of the vectors. None of these are about the units, fundamentally. So it seems to me that there's a missing part here, right? And that might be moving between incommensurate units. But this is actually a skill that people have if we're doing physics, if we're doing mathematics, if we're doing, whatever in daily life. You do know how to do this. There are rules for it, and you are, to some degree, taught how to do it. It's just not treated as its own thing, which is interesting because we can break this movement between units down to the same degree, right? Because we can have sort of a measurement system where what we're doing is we're discovering the unit relations between possible units that we could be using, right? So, for instance, say we are looking at a cat and a dog, right? So we have an equation like 3 dogs plus 2 cats. Well, this can yield all sorts of things that are interesting, right? How many tails are involved? How many legs are involved? How many eyes, right? So 3 dogs plus 2 cats should give you 10 eyes, assuming these are typical standard dogs and cats. Nobody's missing an eyeball. Nothing, nobody has extra eyes. It's, they're just standard. If your default assumption of what a dog and a cat look like, right? So here we get a case where 3 plus 2 is 10, because what we're doing is we're looking at units, not the scale, not the magnitude of the unit of the vectors, right? So this is an entirely, really untapped, unappreciated aspect of mathematics, but you are trained to do it. And the next step up from measurement is arithmetic. Well, arithmetic, when we're doing this, when we're rescaling units, we just call that unit conversion. And we have a name for this. So, like centimeters to inches, or a mouse's leg to a giraffe's leg, or something like that. Like, it's scaling the unit. We think of it as it's about the number, but it isn't. It's not about the number. It's about the unit. So, unit arithmetic is unit conversion. And similarly, like I noted earlier, geometry in this sense is basically the same thing as arithmetic, right? Because what you're going to be doing is rescaling unit spaces. So you're going to get something like cubic centimeters to cubic inches. That's effectively the same as the arithmetic side, which is a centimeter to an inch. Like, in a lot of senses, arithmetic and geometry are, at this very coarse level that we're looking at it here, effectively identical. But then it seems to, past this, it seems to start getting troublesome. We seem to start running into places where we tend not to recognize this as math anymore. So the algebra side, relative rescaling of units, and then we can come back to, as an example, the 3 cats plus 2 dogs equals 10 eyes thing, where 3 plus 2 can validly equal 10. Conventional mathematics does not work here. And beyond this, like the analysis side of this, I haven't even tried to look at yet, because why? Why try to go further than the first roadblock when I haven't properly dealt with the first roadblock? But I do find it notable that if you don't have some understanding of this level of it, which we don't name, which we don't really talk about, we don't acknowledge as a branch of mathematics, or as anything, if you don't understand it, word problems in math are exceptionally difficult, right? Because you have this little story about Pete and Jane having, going fishing, and they have 10 pounds of sandwiches and 3 pounds of God knows what else, and 16 pounds of tackle, and they walked 7 miles, and it took Pete 4 hours, and it took whoever else I said 2 hours, and right. So you're tracking all of these different things throughout the thing, and then at the end it's like, how much more sandwiches did Jane eat than Pete? Right? You get to the end, and it picks out one of the units of all of the many units that were described, and you're trying to figure it out. Here in these word problems, it's always going to resolve that you get an equation that is all commensurate units, because they're afraid. But the way that the whole thing was set up in the first place, there was all sorts of incommensurate units, and you have to pick out what's commensurate. You have to pick out what makes sense. We can easily take this just a tiny bit further and not have commensurate units in there at all with our question, and the question can still be answerable, right? So you can nudge this just a bit further and get to the thing that I'm talking about here. But even as it is, if you were able in school to handle word problems fairly well, you were doing a version of what I'm talking about here, right? This is not a mysterious foreign thing. This is not something that I just made up and I'm being a dick about it. This is something very, very real that human beings deal with on a daily, in their daily lives. So it's interesting to me that we're sort of ignoring. At one end, we're just not acknowledging the measurement as part of mathematics, right? How do you get these values that you're manipulating? If math is about numbers, where are the numbers coming from? You have to define your units in order to get the numbers. So that's important. And then you have to actually take a measurement to get the numbers too. So there's a lot going on before you can even get to what we consider to be math, which is arithmetic and geometry and algebra and all that shit. Okay, there's a lot of important things going on there beforehand, and kind of don't acknowledge it. But on the other hand, all of the math that you recognize, we're handling these vectors, which are number unit pairs, right? But all of the math that you recognize as math, everything that is considered to be math, handles only manipulation of the number side. Anything that's a manipulation of the unit side is not really math so much, or it's just kind of like there's some little tricks here and there, like how do you do unit conversions, and for the most part we just like, wow, get that out of the way and then it's done, and it's not math, it's just whatever. And nobody seems to recognize, like, well, in order to convert from centimeters to inches, I'm going to divide the centimeter measurement that I have. So say I have 43 centimeters or something. I'm going to divide that 43 centimeters by centimeters and then multiply it by inches. Okay? I'm not dividing it by a number. I'm dividing it by a unit type. And then I'm multiplying it by a unit type so that I end up getting centimeters divided by centimeters, which is 1. Unit divided by itself is 1. Anything divided by itself is 1. And this is the naked, unsigned 1, right? This is the bare number 1, right? It's not an integer 1. This is the multiplicative identity 1. And you can get at it by dividing absolutely anything by itself. So the notion that math is about numbers is frankly insane, because in order to ever do unit conversions, you have to recognize that you're dividing units by units, not numbers. There's no numbers here. There's some, numbers come about in the rescaling, right? Because there's centimeters are smaller than inches, so 2.54 of them fit into an inch. Yes. And what you're doing, right, so you're, what are you doing? So 43 centimeters is being divided by 2.54 centimeters, and then that is being multiplied by 1 inch, okay? All of these numbers are our integers, okay? But, well, no, they're not, all of these numbers are real numbers, okay? Which means that they are signed, and they have units attached to them, so they're vectors, okay? But we can abstract the number part away. We can separate that off, and we can just say it's 43 divided by 2.54 and abstract away the fact that it's multiplied by the 1 from the inches, right? So 43 on 2.54 as one component times centimeters divided by centimeters. Centimeters divided by centimeters is just 1. Well, it's the number 1. Okay? Which means that we're just getting all of what we're talking about here. So that we can ignore. We can ignore the centimeters divided by centimeters. We can just make it disappear, like we did the 1 off of the inches. And now all we have is 43 on 2.54. No units, right? These are still vectors, but we strip them of their units. And then because we have the multiplication by inches, that becomes our new unit. In the middle of the math, what you did is you stripped away the unit, right? This isn't even a proper thing yet. This isn't a proper mathematical object until you put the unit back on. But the way that we think about it, you tend to just handle the number side. And kind of like, oh, well, yeah, just hand wavy about the units. You know, that's wrong. That's not how you should be doing this. That's not how you should be thinking about this, I don't think. In order to do math properly, you have to understand at some level the things that I'm saying right here. And yet, people will declare that I'm wrong and that I'm making this up and that this is nonsense. It's amazing.